Okay, so this video is going to be, they pop up every once in a while and won't be every section, like it won't be 7.1, but sometimes I think there are extra homework problems that we don't have time to cover in the main video, so these are optional supplementary videos if you want to see me do some different kinds of problems that we maybe didn't get to do in the videos. So we're going to start by looking at 14, which is this section. So find the lengths of the missing sides if side A is opposite angle A, side B is opposite angle B, and side C is the hypotenuse. So if you just take a moment to parse that a little bit, then what you're going to get is you're going to get a triangle that looks like this. Let's write it in. Wait, you guys want to see something really cool? Watch this. Get a triangle that looks like this. All right, it's not that cool, because it doesn't perfectly work. But look how straight that triangle is. It's like I really know. All right, so we got the right angle right here. Oh, I've ruined it already. Shouldn't have spoiled you. So C is the hypotenuse, and then it doesn't matter which one you label A and which one you label B. But the idea is that the little letters are the sides, and the little letters are opposite the big letters. So angle B is opposite side B, and so on. So that's really what it's trying to say with these problems. Okay, so we got problem number 14 is how we're going to start. And in problem 14, we have that sine of B is 1 over root 3. Sine of B is equal to 1 over root 3. We won't really be rationalizing the denominator in this class. It's good to know how to do it, but we're not going to care that much in this class. And then A is 2, little a is 2. All right, so if we're just updating our little picture over here, we can say that A is 2 right here. And so there's a couple of things that are going on right here. This is actually a little bit more of an advanced problem than the earlier ones in the same section, but what we have right here is kind of good enough. So be very careful. It's really tempting to just say, oh, sine of B is 1/3. Find B, that's opposite over hypothesis. Hypotenuse. But this is not correct. The reason this is not correct is because this is a ratio right here. Okay? But remember that ratio goes for triangles that look like this, for triangles that look like this, for triangles that look like this. We don't know how big the triangle is. We are only given the ratio right here. Okay? So be very, very careful when we're doing this. So we know that the sine, we know the ratio of these sides, but we don't know the actual values. Okay. And so this one's a little weird. So the ratio is, let's say we don't know what B is, but I do know that C is the square root of 3 times B. Okay. So whatever B is, C is the square root of 3 times B. And so if A is 2 and we have this, then what we can do is we can use the Pythagorean theorem. Okay? Because we need more information essentially. So if we use the Pythagorean theorem, what we're going to have is A squared plus B squared equals C squared. Be very careful. I'm going to include parentheses right here to make it a little easier to kind of see what's going on. And then let's simplify. We're going to get 4 plus B squared. When you square a monomial means everything's multiplied, nothing added or subtracted. When you square a monomial, we're going to get square root of 3 squared. Like the squared goes to both, essentially. So square root of 3 squared is 3. B squared is B squared. Let's get all the B's together. Okay? Let's subtract B squared from both sides. And that's going to give us 4 is equal to 3B squared minus 1B squared is now 2B squared. Divide both sides by 2. And then we're going to get that 2 is equal to b squared. So b, when you square root both sides, you have to give a plus or minus. But because we're dealing with triangle lengths, we only care about the positive one, right? Side length can't be negative. Make a little note. Side length has to be greater than 0. So that's why we can throw out that negative sign right here. Okay, so we know what b is. B is the square root of 2. Yeah, let's write our answers in green. And so let's write this answer in green as well. And then the last answer, we don't know what c is, but we know c is the square root of 3 times b. So if c is the square root of 3 times b, c is the square root of 3 times the square root of 2. That's the square root of 6. All right. And there we, whoa. And there we have it. We have the answers. So let's check our answers, right? So this is the answer. We have the answers written down right here. Right? B is square root of 2. C is the square root of 6. That's what we're asked to do. Let's make sure that the information that we were given is correct. If we look at the sine of b, the sine of b is the opposite over the hypotenuse. The sine, cosine, and tangent are all just ratios. So this is what ratio this one is. So the opposite of b is the square root of 2. Divided by the hypotenuse, that is the square root of 6. And if we simplify this ratio, we get 1 divided by the square root of 3, which is exactly what we thought sine of b was supposed to be. So it checks out. And there we go. So usually the problems in this set aren't that complicated, but I wanted to kind of give you an example and kind of talk about this language as well. All right, let's do another one. 14. Nope, we just did that. 24. From the textbook. All right, evaluate each trig function of a. So 24 says find the cosine of a. So this one's much simpler. Let's copy the problem down. 10, 8. And this is a. And it wants us to evaluate the cosine of a. So again, the cosine of a, that is going to be the adjacent divided by the hypotenuse. Right? SOHCAHTOA. So the adjacent for a, well, that's easy. The adjacent is the one that's right next to it. That's 8. Divided by the hypotenuse. We don't know the hypotenuse, right? What's the hypotenuse? Again, we're going to use Pythagorean's theorem. So let's go off to the side. A squared plus b squared equals c squared. And then just solve for c. So again, very similarly to before, we're going to get 164 is equal to c squared. That is nothing nice. So we'll use an approximation here. Usually I'm going to be very clear on whether I want an approximation or an exact answer. But the book doesn't specify right here. So if we look at the square root of 164, that's going to be 12.8062 approximately. Four digits is a pretty safe bet for this class. If you're ever in doubt, or you can write this as a simplified radical as well. 164, if you wanted to simplify it, right? C is also equal to the square root of 164, which is like 4 times 41. So that's 2 root 41. Again, this right here is the approximate, and this down here is the exact. All right. So you can choose whichever one you want. Let's use the exact right here. But usually I'll specify. The book doesn't specify here. We'll cancel a little bit. 8 over 2 simplifies to 4 divided by 1. So we're going to get 4 divided by the square root of 41 is the cosine of a. And again, you don't have to rationalize the denominator in this class. This is an A-OK final answer. Do one more problem together, number 30 from the textbook. Again, all of these are from the textbook. All of these are very similar to your homework problems. That's why I'm doing it. Solve for the unknown sides of the given triangle. So again, let's just copy this triangle down. Okay. Which is a good problem solving strategy in general when you're doing problems at home. So this is A. This is 60 degrees on the right. And little a, again, little a opposite big A. This is very, very common notation. All right, C is on the bottom. Again, very common for the hypotenuse to be C. And D is over here. Every time you're copying a problem down, especially like quizzes or exam questions, just double check and make sure that you copied it down correctly, okay? Because it's a very common mistake. So we need to find the missing sides. It didn't say that we needed to find the missing angle, but remember that all sides, ooh, that's not true. All angles in a triangle add up to 180. So 90 plus 60 plus whatever this is needs to be 180. So we do know that A is 30 degrees. Oh, this is a special triangle. This is a 30, 60, 90 triangle. Remember 30, 60, 90 triangles, if you want to go off to the side. It's helpful to orient them the same way. So you can either write them both in standard form or both in this way. Have the short side of length S. The hypotenuse is always going to be double the short side. And the long side is going to be the square root of 3 times S. This is a special triangle. 30, 60, 90 triangle. So we have this. This is the short side. The short side is always half of the long side. So once we find A, C is just going to be double A. So if 10 is the square root of 3 times S, let's write that down. 10 is the square root of 3 times the short side. And if we wanted, right, we could actually replace all of these S's. We could replace all of these S's with A's, right? This is literally called A right here. So if 10 is the square root of 3 times A, well, then I know exactly what A is. Divide both sides by the square root of 3. And again, you don't have to rationalize the denominator in this class. We're going to get A is just 10 divided by the square root of 3. That's great. And then C, again, is always just twice the short side. The hypotenuse of this special triangle is twice the short side. That's going to be 20 over the square root of 3. And those are our answers. Voila. Okay. And that's selected homework problems. Again, I'll add these sometimes depending on how the section's looking and whether I think that it would be a good idea to have extra problems. So hopefully these are helpful, and good luck.